Something unusual has been spotted on the moon, and it's getting attention for a reason. New high-resolution observations linked to NASA's Artemis program revealed areas where the lunar surface appears to have shifted, cracked, or partially collapsed. In some images, it even looks like a section of the moon has broken away. At first glance, this sounds extreme. The moon is usually described as geologically inactive, a stable and unchanging world. But the data tells a different story. Certain regions now show surface features that were not clearly visible in older imagery, suggesting relatively recent changes. The key to understanding this lies in how the moon actually evolves. Even without plate tectonics like Earth, the moon is still slowly changing. One of the main reasons is temperature. The lunar surface experiences extreme swings from about 120 degrees Celsius during the day to 130 degrees Celsius at night. These rapid changes cause the surface material to expand and contract over and over again, gradually weakening rock structures. Over time, this leads to cracking. Another major factor is the moon's internal cooling. As the moon slowly loses heat, its interior contracts. This process creates stress in the crust, forming features known as lobate scarps, which are essentially small cliffs or fault lines. Data from NASA's Lunar Reconnaissance Orbiter has identified thousands of these structures, some stretching for several kilometers. What makes them important is their age. Many of these scarps appear relatively young, which suggests the moon is still tectonically active on a small scale. There is also direct evidence of seismic activity. Instruments left on the surface during the Apollo missions recorded moonquakes with magnitudes up to about 5.0. These are strong enough to shift surface material, especially in areas where the ground is already unstable. Recent analysis shows that some of these lunar faults may have been active within the last 50 million years, which is extremely recent in geological terms. In some regions, boulders up to several meters in size have been observed at the base of cliffs, likely dislodged by seismic activity. Computer models suggest that even a moderate moonquake could trigger cascading rockfalls across unstable slopes, especially near the lunar poles where future missions are planned. This means that what looks like a small surface crack in satellite images could actually be part of a much larger and ongoing structural shift. In several locations, high-resolution images show slopes that appear to have partially collapsed. Loose material has moved downhill, leaving behind fresh-looking surfaces that stand out from older terrain. In some cases, this creates the visual impression that a chunk of the moon has broken off. In reality, these are most likely landslides or regolith movements triggered by moonquakes, temperature stress, or both. Micrometeorites add another layer to the process. The moon has no atmosphere, so even tiny particles strike the surface at high speeds. Over time, these constant impacts disturb the upper layer of dust and rock, making it easier for material to shift when other forces act on it. All of these factors combined make the lunar surface more dynamic than it appears from Earth. For scientists, this is not just an interesting detail. It has practical implications. Missions like Artemis are focused on long-term exploration, including future landings and potential infrastructure on the moon. Understanding which areas are stable and which are prone to change is critical. Regions with active fault lines or loose surface material could present risks for landing spacecraft or building equipment. That is why updated mapping and continuous observation are so important. At the same time, these changes provide valuable scientific insight. They show that the moon is not completely inactive. It is still evolving, slowly reshaping its surface through small but continuous processes. The idea that a massive piece of the moon suddenly broke off is not supported by current evidence. But smaller-scale changes are happening, and they are measurable. And in some cases, they can look dramatic enough to raise new questions. Because when we look at the moon with higher precision than ever before, we are starting to see something unexpected. A world that seemed frozen in time is still changing.
August 23, 2023, a day when India's Chandrayaan-3 spacecraft made history by becoming the first to touch down on the lunar South Pole, a place we can't normally see from Earth. What makes this lunar hideaway so fascinating to scientists? Well, it turns out it's hiding something precious: lunar ice. This place is believed to be more abundant with this ice than what we found up north. And it's not hard to see why scientists are so buzzed up about it. It's a frozen water source, and it could become our key to building a permanent lunar home, or even fueling missions all the way to Mars. Scientists knew about this ice for over 2 decades, since the NASA spacecraft accidentally stumbled upon it during one of the missions. Then in 2018, NASA triumphantly declared that they're 100% sure about it. They said that the south pole of the moon is abundant with water. Now picture this. Future lunar settlers could tap into this water supply. It could help us sustain life in the barren lunar landscape. Plus, by cleverly splitting the water into oxygen and hydrogen, we could receive both air and rocket fuel. All this will make moon missions more feasible and self-sustaining. It's also a great glimpse into the past. This ice, maybe as old as the moon itself, could unlock the moon's and Earth's deep mysteries. But it turns out that water isn't rare in space at all. There might be lots of planets out there where life could thrive. We know this because we started finding water vapor around stars, and this water is remarkably similar to the water in our own solar system. This discovery suggests that the water on Earth originally came from space. Water forms around stars in the cloud of extremely hot vapor. Then it turns into ice and sticks to tiny dust particles. These particles stick together over time and become bigger objects, like comets, planets, and other things. Some of these become comets and planets in our own solar system. And this is how water is being spread across the universe, and it may be how it got to our planet and the moon too. Scientists think that the lunar ice might have journeyed here eons ago. Maybe it hitched a ride on water-rich asteroids that smacked into the moon's surface. All this has big implications for us. The southern pole is an ideal canvas for humanity to establish a real moon base. Imagine brick domes connected by secret underground tunnels. They'll be bustling with people busily operating computers. Some others will be cruising the lunar landscape in their jeeps or on their way to mine precious resources. We have some pretty cool ideas on how to build this. First, you probably imagine hauling hefty and water-draining shelters all the way from Earth. But maybe there's a more effective way. Think about our history as a civilization. Every time we ventured to a new place, we surveyed the surroundings for available resources and used them to survive and thrive. This is how we spread across our own planet. So why shouldn't we spread across the moon the same way? Now, you might wonder what resources the moon might offer. We know about the ice, and it can be turned into water. But we can clearly see that our planet lacks lush greenery and edible food. Well, it might not be obvious, but the moon does have something to offer: mineral resources and sunlight. Unlike Earth, where the sun rises and sets, the lunar poles offer quite a beautiful sight. The sun gracefully orbits the horizon the entire day, which means it can provide an almost uninterrupted source of power. Imagine living in a world bathed in perpetual sunlight. I'm sure the solar panels will love it. Me? Not so much. Still, we could use not only the sun's light, but also its heat. Honestly, we should just use everything. If we're left with spare metal while producing oxygen, find a purpose for that metal too. We need to treat the environment responsibly, not only on Earth, but on the moon as well. Which is why scientists are learning how to turn the moon's most abundant resources, regolith, into sturdy bricks. They've been quite inventive in figuring out how to create moon bricks. Scientists want to use the sun's heat to melt lunar dust, layer by layer, essentially creating a 3D printer for moon dust. Engineers have also cooked up bricks using solar ovens and zapped lunar soil with microwaves. They become quite adept at it. So yeah, perhaps we're going to establish a little brick factory on the moon and build regolith houses. It's like Minecraft in real life. As soon as you find some cool new material, you gotta build a tiny house with it. If successful, these bricks could be used to construct entire buildings, potentially covering inflatable modules or giving new life to abandoned landers. So, will astronauts need to become skilled bricklayers? Well, they won't do everything themselves. We'd have to create a small automated system involving robots working collaboratively. Humans will, of course, oversee the construction site. Despite all this automation, scientists believe that living on the moon is going to be, well, call it cozy. The designs may involve stacked living quarters or multi-purpose areas. However, there would be some challenges too. On the moon, things get extreme. Imagine scorching temperatures that can go up to 212 degrees Fahrenheit during the day, and at night, they plunge down to a chilly minus 290 degrees. And it's not just the weather. The moon gets relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these things gradually wear down anything on its surface. Another big challenge is the lunar dust. On the moon, there's no air to breathe, and the dust there can cause problems. And this one isn't only regular dust. It's super clingy and can even make astronauts sneeze and have watery eyes, as if they're having a lunar hay fever. It can also damage equipment and spacesuits. It's not something you want to mess with. Scientists have found that the dust is made when meteors hit the moon, creating tiny particles and sharp glass shards. It's toxic, and its tiny particles can float around in low lunar gravity, making it hard to breathe. Unlike on Earth, the moon doesn't have wind or rain to clean it away. So now they're studying it to find out how to prevent this annoying problem from ruining their entire mission. There's more to this lunar haven than meets the eye. Scientists also want to delve into the mysteries of low-frequency electromagnetic waves there. These waves are whispers from the far reaches of the universe. These elusive signals have remained hidden from us for ages. We only caught some cacophony of radio and other background noise, but that's it. On the moon's dark side, however, we can finally record and study them. Studying these waves will help scientists to unlock the secrets of the universe's origins. It's not just about the Earth or the moon. We're talking about peering back to the very beginnings of our world. Our new lunar lab might help us to forever reshape our understanding of the cosmos. So, NASA has some big plans on the moon now. Their Artemis mission completed a successful return to Earth in December 2022 after nearly a month in space. It ventured far beyond the moon. This mission proved the capabilities of some of our recent technological developments that will help us explore Mars. The goal of Artemis is to establish a lasting presence on the moon. They want to create a gateway, like a space station in orbit around the satellite, to help with the landings. Artemis 2 is set to carry astronauts to lunar orbit in 2024, and during Artemis 3, which should take place in the mid-2020s, 2 astronauts will touch down near the moon's south pole. It's quite possible that the lunar base will be built within the next couple of decades. So, stay tuned. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the Moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the Moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the Moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire Moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the Moon's surface and its core, called the mantle, has been moving around as the Moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the Moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the Moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the Moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the Moon's magnetic field. Knowing what the inner core is like can help us better understand the Moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the Moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the Moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one skywatcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too? Whew, okay, big relief. 2024 YR4 isn't going to hit Earth and wipe out entire cities. But this huge asteroid could still hit the moon by 2032. The impact could blast a massive cloud of dust and debris into space, putting satellites and astronauts at risk. So NASA is now considering a bold Armageddon-style solution to blow it up. This asteroid was first discovered back in 2024, thanks to the Atlas Survey telescope in Chile. Now, its official name is 2024 YR4, but hey, let's just call it Nugget for short. So, Nugget is huge, about 200 feet across, which is like a 15-story building. If something that big hit Earth, it would be catastrophic. It could wipe out major cities like London, Paris, or New York, and if it hit the ocean, it could trigger massive tsunamis. Now imagine the scientists' surprise when they ran the numbers and realized that, wait, there's a real chance it could hit Earth. And at one point, the odds were about 3%. Now, that doesn't sound like much, but with city-destroying potential, you want that number at 0, right? That's how this big guy became the first asteroid to trigger a coordinated international planetary defense response. Thankfully, by March 2025, space agencies had enough data to rule out an Earth impact. In fact, there's no serious threat from this asteroid for at least the next 100 years. So that's the good news. But then a new problem showed up. It might hit the moon. New projections say there's a 4% chance that it could hit our natural satellite in December 2032. The scary part is that the odds might actually be higher, maybe a lot higher. And we might not know for sure until there's barely any time left to do anything about it. Because right now, Nugget is simply too far away to study any further. It's hidden from our view, and scientists say we won't be able to spot it again until June 2028. And only then will space agencies be able to take new observations and confidently figure out whether the asteroid will, or much more likely, won't hit the moon. But what if they actually find out that Nugget is actually on a collision course? I mean, should we intervene? Well, some scientists think we should. After all, it could still be dangerous for astronauts, and it could even knock out stuff we rely on down here, like the internet, cell service, and GPS. If this asteroid did collide with the moon, the impact would be so huge that it would likely be visible from Earth. But honestly, no one knows what exactly would happen, and there's a reason for that. When small space objects hit Earth's atmosphere, they usually burn up. But the moon doesn't have that kind of shield, so it gets smacked all the time by asteroids and meteorites. Estimates show about 100 space rocks hit it every single day, and most are tiny, basically the size of ping pong balls. But an asteroid the size of Nugget is a whole different story. Actually, it's really rare for something that big to hit the moon, and it only happens about once every 4,000 to 5,000 years. And it's even rarer that we know about it ahead of time. So, scientists will probably run a lot of detailed computer simulations over the next few years to see what might happen. But they're already pretty sure the impact would leave a brand new crater on the moon, roughly 3,000 feet wide. And right after Nugget hits, the blast would kick up a massive spray of regolith into space. By that, I mean the dust and small rocks covering the moon. The problem is, we wouldn't be able to predict ahead of time exactly how much material would get launched into space, or whether any of it would reach Earth. Some say the number of tiny space rocks hitting us could jump to 1,000 times the usual level, and that could last for a few days. On the bright side, an event like this could turn into one of the best meteor showers ever. But here's the problem. It wouldn't just look cool. It could be really dangerous for astronauts on the ISS and other space stations. It could mess with satellites and turn into a real headache for all of us down here. And yeah, we definitely don't want that. So, scientists are working on a plan to make sure Nugget doesn't hit the moon at all. And when it comes to stopping a collision like this, there are really only two options: deflect the asteroid or destroy it. Ideally, you just want to deflect it. The idea is to give this asteroid a little push so it changes its trajectory and doesn't hit the moon. And the earlier you do it, the smaller that push has to be. But this method comes with a catch. To deflect Nugget accurately, we first need to know how much it weighs. And that's harder than it sounds, because estimates of its mass depend on its density, which is tough to figure out from that far away. The asteroid could weigh anywhere from 51 million to over 711 million kilograms. And depending on where it falls in that range, the energy needed to nudge it the exact right amount could be completely different. And the problem is that if a deflection mission is based on the wrong mass estimate, you could accidentally nudge it the wrong way. That could make the problem worse, including, in the worst-case scenario, redirecting it toward Earth. So yeah, maybe we should just drop that idea. And scientists basically agree. Which brings us to option number 2, destroy it. Now, there are two ways to do that. The first is using kinetic energy. Basically, you hit it with something big and heavy enough to break it into smaller chunks. We've actually seen this kind of idea work. NASA's DART mission showed that, yes, you can change an asteroid's trajectory by crashing a spacecraft into it. But crashing into a huge space rock with the real goal of destroying it? Well, that's a whole different level of difficulty. Maybe we'll have the tech to do that by 2030, maybe we won't. The second way to destroy an asteroid is something called a height of burst. So basically, you set off a nuclear device close to the asteroid, just above the surface. NASA studies say a 1 megaton nuclear blast would be enough to destroy Nugget, no matter what size or how heavy it is. We have never actually tested a nuclear detonation in space specifically to deflect an asteroid before. but the physics says it can work. So at this point, it's not just a technical call, it's more like a big global decision. Authorities still need to figure out if it's worth doing all this for this particular threat. And remember, for now, there's still a 96% chance this asteroid doesn't hit the moon. So we just have to wait a few years until it comes back into view to update these numbers. All of these plans are still just possible scenarios that space agencies are talking through. And any final decision would be made over the next few years. The timing would be pretty tight though. If they want to be ready for 2032, a nuclear mission would have to launch sometime between late 2029 and 2031. Now, even if Nugget never hits anything, tracking its trajectory and thinking through how we'd stop it is still a really valuable test run for planetary defense. And keeping an eye on threats like this is only getting more important, especially as space agencies move closer to building bases on the moon, where astronauts would live and work. The United States plans to start launching regular missions to the moon before NASA eventually heads to Mars. China has similar plans too, and has said it wants to land its astronauts on the moon by 2030. That's why we need sharper tools and better prediction, so everyone can stay safe up there in the future. And hopefully, Nugget, or any asteroid like it, never becomes a threat to us.
Recently, Chinese scientists discovered something interesting on the moon, an unusual crystal. Moreover, they found out that this crystal contains an element that can literally replace nuclear fuel. Let's find out more. The composition of the moon has long remained a mystery to us. Half a century has already passed since the Apollo mission. Unfortunately, we haven't traveled to the moon much since then. So it's not surprising that it's not so easy for us to study it. But recently, we've made a breakthrough in this area. In December 2020, Chinese scientists sent the Chang'e 5 probe to the moon. The mission was named after the ancient Chinese deity of the moon, Chang'e. Quite poetic, isn't it? Anyway, after the probe went to the nearest side of the moon, it spent several days digging through the surface and rocks, and then returned to Earth. In total, it collected about 4 pounds of various lunar rocks, like basalt, solidified lava, and so on. And yeah, maybe it doesn't sound too impressive, but it's actually a mini breakthrough. After all, we hadn't received any lunar samples since 1976. And these samples are very important for learning the history of our world. We've been struggling for many years to find out, for example, how the moon was born at all. Yes, there were a lot of theories, but we still couldn't find any proper evidence for any of them. But thanks to the latest missions and some computer simulations, scientists finally found out the truth. The moon was born when some random dwarf planet crashed into our Earth many millions of years ago. This dwarf planet was slightly smaller than Mars. The fragments of the Earth went into space, but some of them stayed in our orbit. Then they stuck together and formed the moon. It sounds horrifying, but in reality, the birth of the moon was the best thing to ever happen to our planet. If it weren't for this beautiful satellite, all our oceans would be small puddles. Life wouldn't have appeared on Earth at all. So this is already an amazing discovery, but that's still not all. Studying the collected rocks, scientists from the Beijing Research Institute discovered something unusual, a rare lunar crystal. Looks pretty boring, doesn't it? Just some tiny transparent monocrystal about the thickness of a human hair. We've already found such things on the moon before. These crystals were formed as a result of volcanic activity, just like some garnets on the Earth. And yep, the place where they discovered these crystals also suffered from volcanoes 1.2 billion years ago. That means that this tiny baby is over 1 billion years old. But that's not the most important thing. It's the fact that this crystal is made of a unique material, the one that we've never seen before. Researchers from the International Mineralogical Association have confirmed that such a composition can't be found anywhere on Earth. The crystal was named Chang'e, again after the same moon deity. And this is another achievement. This is the 6th previously unknown mineral that we've found on the moon and the first one found by China. Now, it has become the third country in the world to make such a lunar discovery. However, this tiny crystal still wasn't the only remarkable thing they found. After studying this gem and about 140,000 other lunar particles, scientists have discovered something else. They found helium-3. Why is it so important? Because this is one of the elements that feed the sun and other stars in our universe. We tend to say stuff like, put out the sun is burning, and so on. And this is one of the reasons why many people actually think that the sun is a huge fireball. But it's not. Its burning is actually a completely different process, which is called nuclear fusion. The process itself is quite simple. During this reaction, hydrogen in the star turns into helium. But this simple process is actually one of the most violent and insane reactions in the universe. There's a real boiling broth of particles inside the sun. The hydrogen nuclei that jump and rush there are constantly repelling each other since all of them are positively charged. And so they could continue to boil and chill around without bothering anyone if it weren't for the stars. The stars turned out to be cheaters. They have such strong gravity that they basically grab billions of these little atoms and squeeze them together. Combining with each other, these atoms create new heavy elements, like the mentioned helium. And when this happens, they throw a lot of energy into space. And that's how the sun burns. At the same time, it spreads so much energy that we can't even imagine. Okay, so what is helium-3? Well, this is an element to which even the sun can say, "Whoa, dude, you should calm down." The fusion of helium-3 atoms releases even more energy than in typical nuclear fusion. And most importantly, it doesn't pollute the atmosphere with harmful things like radiation. We have very, very little helium-3 on Earth. Its prevalence in our atmosphere is about 1 in a million. And besides, it's constantly trying to escape from us back into space. Probably feels some bad vibes from us. However, scientists have recently found out that there's a place that contains a lot of this element. Yep, you guessed it, it's the moon. We think that there's more helium-3 on the moon than on Earth because of the solar winds. The sun has been hammering on the moon with its helium-3 for billions of years, so now it's all over the place. It's still not too much if you compare it, for example, with Jupiter or Saturn. But don't forget how much energy it can release. For your information, with only 25 tons of helium-3, it's possible to provide America with energy for an entire year. Now, there are 35,000 tons of it here on Earth, and more than 1 million tons on the moon. Only these sources could feed the entire US for thousands of years. So basically, in the future, helium-3 may become a new source of fuel. And it's better than nuclear fuel in basically everything. Helium-3 won't leave any harmful waste and radiation. It's more powerful and not that dangerous. In other words, this environmentally friendly and efficient energy could be a revolution for our planet. Sounds cool, huh? So, what are we waiting for? Grab the shovels, you might say. But there's a little problem here. Unfortunately, we haven't yet come up with anything as wildly strong and hot as the stars. To use helium-3, we need crazy temperatures and pressure. We need a thermonuclear reactor, and we have no idea how to build it, yet. And even if we could heat it up to such temperatures and get the needed pressure, we still don't really know how to handle helium-3 correctly. Therefore, even if we have an infinite amount of helium-3, we still won't be able to use it. But still, there's a great power behind helium-3, so it's not surprising that different countries have already started a race for nuclear resources. Now that Chang'e 5 has discovered a new helium-3 deposit on the nearest side of the moon, this race can become downright global. For example, China already plans a new lunar mission in 2024, Chang'e 6. During this mission, they want to collect the first samples from the far side of the moon. As you can see, finding this lunar crystal was very important for us. These crystals can help us find new ways to create helium-3. And if we manage to do that, humankind will enter a new era. But to do this, we still have to solve a number of problems. How to deliver a bunch of these lunar crystals to Earth, how to make them produce energy, and so on. Let's hope that in the future these issues will be resolved and we'll find a way to produce clean, safe, unlimited energy.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus,
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus,
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that. Now, don't get all upset, but the moon is shrinking and getting wrinkled, pretty much like a grape turning into a raisin. That happens because our natural satellite has been retaining its inner heat for over 4 billion years, but its core is gradually cooling down and becoming more dense, like me. Unlike a grape's flexible skin, the moon's surface is pretty brittle. This brittleness causes faults to form where different sections of the crust push up against each other, leading to what scientists call moonquakes. So far, our satellite has shrunk by around 150 feet in circumference. It's such a tiny change that it won't affect the look of eclipses or the phases of the moon. Even tidal cycles won't be affected since the moon's mass hasn't really changed. The shrinking process won't directly affect us down here, but that doesn't mean that all humans are safe. Moonquakes caused by the shrinking process have been a concern for years. During the famous Apollo missions, NASA astronauts left seismometers at different points on the moon. Those are devices capable of identifying seismic activity on the lunar surface with exceptional precision. The equipment was operational for several years, and it managed to capture over 12,000 moonquakes ranging in magnitudes from 2 to 5. Up until 1977, the team was able to identify 4 distinct types of quakes. Some tremors, like those caused by meteorite impacts, were relatively easy to identify. But the cause of the so-called shallow moonquakes remains a mystery to scientists, and that can be an obstacle to future missions on lunar soil. As the name suggests, shallow moonquakes occur relatively close to the surface, typically between 30 to 135 miles beneath the surface. Recent research suggests that these tremors are triggered by the compression of the moon's surface, leading to the formation of thrust faults, where one surface layer is pushed up over another. This study also discovered where the epicenters of the strongest ones were. It all started in the South Pole region, precisely where we want to settle down. Interest in the lunar South Pole peaked in 2023, when India's Chandrayaan mission successfully landed and deployed a rover to explore the area. NASA also has plans for the same spot, and their ambitious goal is to take astronauts there for the very first time. The Artemis 3 mission, scheduled for 2026, currently has 13 potential landing spots at the South Pole, represented by the blue squares here. One of the options is situated within a geological feature called the Gerlach Rim 2, which is a strategic area for exploration. It might have ice, because parts of it are completely in the dark, but it's close enough to areas that do have sunlight, which is crucial as a source of power. Now, take a look at the pink dots on that same map. They represent possible epicenters of the strongest moonquakes recorded by the Apollo missions. That means that thrust faults in the area could be relatively young and potentially active, representing a real danger to the Artemis 3 crew. These astronauts will journey to lunar orbit over the course of 30 days, and 2 crew members will descend to the surface, spending about a week at the South Pole. Their moonwalk will be particularly challenging, given the extreme temperatures of these permanently shadowed regions. The presence of moonquakes and possible landslides only adds more danger to this mission, as this phenomenon is far more frightening than earthquakes. The strongest moonquake ever recorded had a magnitude of 5.7. You might think that's not a big deal, considering that countries like Chile, Colombia, and Papua New Guinea experienced earthquakes of similar magnitude in 2023 without significant damage. But the gravitational pull on the moon is relatively weaker than on Earth, so what feels like a gentle tremor on our planet might be a real ground-shaking event up there. This happens because you're not as firmly connected to the surface of the moon as you are on Earth, meaning that seismic waves can cause the surface to move more freely. There's also a huge difference in duration. Earthquakes typically last between 10 and 30 seconds, with some lasting up to 2 minutes. A moonquake can persist much longer than that. Our satellite is essentially a solid, rigid, and dry sphere. So when a tremor shakes the moon's surface, it resonates powerfully without any natural means of dissipation. Moonquakes can last for a good 10 minutes or even longer, with little tremors sticking around for hours afterwards. Now, these new findings about shallow moonquakes won't actually change the potential landing sites for Artemis 3, and they won't affect the duration of the mission either. That's because accurately estimating how often a specific region experiences these tremors is tricky and unpredictable. What scientists do know is that these shallow quakes aren't very common and pose a low risk to short-term missions on the lunar surface. But that situation changes completely if we consider long-term habitation on the Moon, and that could happen sooner than we expect. The Artemis 3 mission represents an important first step towards space colonization. China is also making the first moves to establish a permanent lunar base at the South Pole by 2040. Their strategy involves utilizing 3D printing and brick production from lunar soil for constructing the moon base. That definitely sounds fascinating, but putting together a setup like that comes with a bunch of challenges, including dealing with intense cosmic radiation, the lack of water, and of course, long-lasting moonquakes. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed, so when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because, without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the Moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Suite mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the Moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the Moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the Moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the Moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. Well, that makes me breathe easier. How about you?
An asteroid broke off the Moon and now it's super close to Earth. Does it pose a danger to us? Kama'oalewa, also known as 2016 HO3, spins super quickly as it orbits near our planet. Let's call it HO3 for short. Astronomers found it on April 27, 2016. Compared to other asteroids, it's tiny. On Earth, though, it would be the size of a small building, or about half the size of the London Eye Ferris wheel. They discovered it in Hawaii, and its name roughly translates to a fragment of something that seems to wobble. After some study, they realized that this asteroid might be a chunk of the Moon that got blasted into space. There's a part of the Moon called Giordano Bruno Crater, named after an Italian philosopher, that guy who had to pay quite the price for his ideas. If you look at it from space, Giordano Bruno stands out because it's surrounded by some rays of material. They're super huge, stretching over 93 miles and are still bright. This means that an enormous boom once happened there. There's an interesting story about this. In 1178, 5 monks were traveling in Canterbury, England. Suddenly, they saw something strange happening on the Moon. They said it looked like the Moon was splitting, with flames and sparks. Then there was a darkening that spread all across the lunar surface. In the 20th century, scientists found these records and thought that these monks saw the formation of the Giordano Bruno crater. But later it turned out that the crater is about 4 million years old. And thank the stars, because such a massive impact, if it really happened in the 12th century, would have gone crazy on our planet. It would have caused a huge meteor storm on Earth. In any case, our HO3 is most likely a piece of the moon that broke off during that impact 4 million years ago. Luckily, there's no need to panic about it. When astronomers spotted this sudden moon piece, they quickly tracked its orbit. Turns out, it won't collide with us anytime soon. It's going to be our quasi-satellite for at least 300 more years, meaning it'll follow a path around the Sun that keeps it close to Earth without colliding. Its orbit is wild though. It seems to be constantly looping around our planet in some pretty unique loops, moving closer and going away, up and down. And then somewhere in the 24th century, it will go even more crazy, switching to a horseshoe orbit, slowly going away from us. Could HO3 collide with us someday? Maybe, but that would happen over millions of years, when it would leave its current orbit and collide with Earth, Venus, or even the Sun itself. Or maybe entirely ejected from the solar system. Even though it's one of the closest asteroids ever discovered, it's also one of the smallest and most stable ones. This discovery also opens up some exciting ideas about life in the universe. We see that rocks can travel between celestial bodies. There is a theory that life could have been spread all across the universe by traveling on these rocks like on some space Ubers, or at least the building blocks of life like carbon. Maybe life even hitchhiked to our planet on rocks from Mars. HO3 probably doesn't carry any life, but the fact that it can travel for millions of years carrying stuff on it and feeling fine supports this theory. Astronomers want to send something to investigate HO3. Back in 2017, a group of students gave an idea of using a spacecraft for it. The China National Space Administration wants to send a robotic probe to HO3 somewhere in 2025. The robot should fly there, collect samples, and bring them back to Earth for study. Unfortunately, you can't see this asteroid in the sky with the naked eye. Its size is about 130 to 330 feet in diameter, so it would be too tiny and dim to see without a super powerful telescope. But there is an asteroid that you'll be able to see, and it will be insane. In 2029, a large asteroid will pass so close to Earth that it will be visible to the naked eye. Make sure not to miss it, because this is a once-in-a-thousand-year event. The asteroid is known as 2004 MN4, or Apophis for short. It's much bigger than HO3, about 1,210 feet wide. This will be the closest asteroid passage ever. This one actually caused some panic back in December 2004, all because there was a 2.7% chance that it could hit Earth in 2029. People were horrified. Even the name, Apophis, is inspired by an evil serpent from ancient Egyptian mythology. A huge monster that fought Ra and always tried to swallow the sun and destroy the planet. Luckily, when scientists got more data, they realized that it would pass pretty close to us in 2029, and we'd be able to see it in the sky. But then, it will just fly away like a chill asteroid. There was another worry though. That during its close pass, Apophis might travel through something called a gravitational keyhole. Basically, that it could travel through a specific narrow region of space which would accidentally alter its orbit. And then it would make an epic comeback in 2036, like the planet from the movie Melancholia. However, after some calculations, scientists ruled out this possibility as well. Apophis will still come quite close to us in 2036, but it will be about as far away as Venus is when it overtakes Earth. And then, Apophis and Earth will just go their own separate ways. On average, an asteroid the size of Apophis is only expected to hit Earth once every 80,000 years. And if it did hit us, it would completely destroy a huge area, causing earthquakes and tsunamis all around the world. But it wouldn't cause an apocalypse or anything like that. You'd only be able to see Apophis from Europe, Africa, and Western Asia. So if you want to see it, you might need to travel. The asteroid will look like a fast-moving star in the night sky, shining bright enough to be seen without any special equipment. It would be easy to spot at night, though city lights might make it harder to see. Now, can you imagine that these are not the only guys hanging nearby? Both HO3 and Apophis are part of the so-called Apollo orbit asteroids. These are the asteroids with orbits going around Earth, an entire group of dangerous fellas. Since they cross Earth's orbit, they have the potential to come close to or even collide with our planet. The first asteroid of this group to be discovered was 1862 Apollo, named after the Greek deity of the sun. It was first discovered in 1932, and the group was named after it. This one was even bigger, almost a mile in size. In fact, it's so huge that it even has its own tiny moon. Apollo crosses orbits of not just Earth, but also Venus and Mars. Fun fact, even though it was the first one of its kind, telescopes accidentally lost it out of view for over 40 years. So scientists went, oh well, let's just keep the count of things we can see. When Apollo was rediscovered in 1973, it wasn't the first asteroid on the list and got a big number in its name. Apollo will fly near us during the next hundreds of years. In 2075, it will be somewhere around Venus, but it should fly by as well. In any case, there's no need to worry, because astronomers are keeping a close track on these guys. If we were in any immediate danger, we'd have known. In order for an asteroid to totally destroy life on our planet, it should be bigger than 6 miles in diameter, like the one that helped to wipe out the dinosaurs 66 million years ago. But these guys are so crazy rare, we'd probably live on other planets by the time they arrive on Earth.